Are there pieces of alien technology scattered across the surface of the moon? What if the discovery of extraterrestrial civilizations doesn't come from a radio signal or a UFO, but from tiny particles that may have traveled across thousands of light years before landing on the moon? Researchers from the SETI Institute, Breakthrough Listen, and several universities argue that the moon could preserve microscopic evidence of extraterrestrial technology that arrived millions or even billions of years ago. Hello, I'm Dr. Alejo. I came across this new scientific paper where researchers propose a new type of technosignature. The authors of the paper discuss the possibility that the moon might be the perfect archaeological site for finding evidence of extraterrestrial technology. Specifically, tiny particles that could be all over the surface of our natural satellite. The authors even calculate how much lunar soil we would need to search before we could begin placing meaningful limits on the existence of ancient technological civilizations in our galaxy. Join me while we review this fascinating paper. Ever since its beginning, the search for extraterrestrial intelligence has focused on listening for narrow-band signals, mostly radio signals. More recently, astronomers have expanded their search space, no pun intended, and have begun also searching for laser pulses in what is known as optical SETI. They are also searching for atmospheric pollution on distant planets, and even gigantic engineering projects such as Dyson spheres, rings, or swarms. But what if alien civilizations have already left artifacts behind, not on Earth, but on the moon? But why search for artifacts on the moon instead of the Earth? Earth is an active planet that experiences rain, wind, oceans, plate tectonics, volcanoes. All these processes erase traces of the distant past. On Earth, very little survives for billions of years. However, the moon presents a completely different scenario. It has no atmosphere, no weather, there are no rivers or oceans, and it doesn't have plate tectonics. The moon was volcanically active for a very long time, but it is now considered geologically inactive, with no evidence of ongoing eruptions. It has remained largely with no volcanism for at least the past 2 billion years. Once something lands on the lunar surface, there is a good chance it will remain there for an incredibly long time. Every day, the moon is bombarded by interplanetary dust. Over billions of years, layer upon layer has accumulated into what scientists call the lunar regolith. Given these characteristics, the authors propose to search for evidence of extraterrestrial technology, but they're not talking about massive structures, monoliths, or alien cities. Human civilization is already producing an enormous amount of debris. We have thousands of satellites, millions of fragments of space junk, microscopic particles created by collisions, industrial dust, paint flakes, and metal fragments. As humanity becomes increasingly active in space, the amount of artificial material escaping into the solar system will continue to grow. Now, imagine a civilization that's millions of years older than ours. Its industrial activity could produce unimaginable quantities of microscopic technological debris, tiny engineered particles, fragments of advanced materials, or even microscopic devices. The paper calls these accidental particles Arkhipov Particles, named after the astronomer Alexei Arkhipov, who was the first to suggest decades ago that technological civilizations might unintentionally, and even without knowing, pollute the galaxy with artificial dust. Searching for extraterrestrial artifacts has many advantages compared to radio signals. Artifacts left by an extraterrestrial civilization don't disappear once that civilization is gone. Think about our Voyager probes, which are on their way out of our solar system and will continue traveling through interstellar space for hundreds of millions of years. But the Voyager's spacecraft have propulsion systems and were engineered to travel through space. Could alien dust really travel between stars? In other words, instead of listening for alien radio transmissions, the authors suggest we search for the microscopic equivalent of space junk. But can microscopic particles actually survive such an incredible journey? According to current astrophysical models, which are explored in the paper, the answer is yes. The interstellar medium isn't empty. It's filled with gas, dust, magnetic fields, and radiation. Tiny particles are constantly traveling through it. Particles released from asteroids, comets, meteorites, and even planetary collisions. The authors calculate that certain particles roughly 3/10 of a micrometer in size, or about 1/100th the width of a human hair, could survive journeys lasting hundreds of millions of years. During that time, they could travel potentially thousands of light years, and eventually some of them would drift into the solar system. However, most would never reach the moon. For instance, many would be deflected, destroyed, or captured by other celestial objects, but a tiny fraction might survive and reach our solar system. Given that the moon has been exposed for over 4 billion years, even if it is just a tiny amount of particles, they could have accumulated over such a long period of time. Up to this point, we've been discussing accidental debris. However, the paper also talks about particles that could have made it to the moon that are not accidental but engineered. They contemplate two types. The first of them are particles that may have been designed to explore or collect information about their local solar system. This could be tiny probes, sensors, self-healing materials. You get the idea. This may escape to other solar systems by accident. As the original plan was to remain local, they may not have interstellar communications capabilities. However, if any of those is found, we could be able to learn about their functionality or even identify them due to their obvious structured microarchitecture. The second type of engineered particles are referred to as Bracewell Particles. These are explicitly designed for interstellar travel and exploration. The name is inspired by Ronald Bracewell's famous idea that advanced civilizations might send autonomous probes throughout the galaxy with the purpose of research and gathering information. We explored this type of probes and other more scary ones in our video about the resolution of the Fermi paradox, which I invite you to check out. These Bracewell particles could be microscopic probes, perhaps capable of sensing their surroundings or carrying stored information. They could be as simple as passive archives, or maybe nothing more than microscopic chips encoded with enormous quantities of data. But there is an obvious problem with this entire idea. If these particles are traveling through the galaxy at tens of kilometers per second, wouldn't they just vaporize when they hit the moon? Most interstellar objects enter the solar system traveling incredibly fast. The Earth moves around the Sun at about 30 kilometers per second. Interstellar dust typically approaches the solar system at another 20 to 30 kilometers per second. Those are enormous speeds. Hypervelocity impact experiments show that microscopic particles striking a surface at more than roughly 5 kilometers per second are usually melted or vaporized. So, how could anything survive? The authors argue that not every particle follows the same trajectory. Microscopic particles are different from asteroids because they are so tiny, they are so strongly affected by solar radiation pressure. At these scales, sunlight doesn't just illuminate dust, but it actually pushes on it. Interestingly, this is the same physical principle behind the proposed breakthrough starshot mission, which hopes to propel tiny interstellar probes using laser light. For particles only a fraction of a micrometer across, that tiny force exerted by the sunlight can gradually alter their trajectory and speed over millions of kilometers. For a tiny fraction of particles, this means that their impact velocity on the moon might fall below about 5 kilometers per second. That's slow enough that some particles, or at least recognizable fragments, could survive. However, this doesn't happen very often. The authors estimate that only about one particle in 10,000 to 1 in 1,000 enters through this slow arrival pathway. But over billions of years, you can end up with small but detectable population of such particles on the surface of the moon. But even if the entire particle doesn't survive, it could leave behind something unusual, an unexpected isotope ratio, exotic alloy, a macroscopic impact fragment that is obviously artificial, which could be taken as strong evidence of the existence of extraterrestrial technology. So, how do we search? This is the cool thing. The moon is small compared to Earth, but it is still a very large surface. However, The author's calculation suggests that examining approximately only 1 cubic meter of lunar regolith could already begin placing meaningful upper limits on how much microscopic technological material advanced civilizations have dispersed throughout the history of the Milky Way. At first, 1 cubic meter sounds like a really small quantity, but remember that a single cubic meter contains billions upon billions of microscopic grains. If technosignatures exist at the abundance predicted by some models, even that relatively small sample could begin placing meaningful constraints. And what if we search and find nothing? This would still be scientifically valuable. A null result allows scientists to eliminate possibilities. It tells us that if advanced civilizations are common, they probably don't produce vast quantities of durable microscopic debris, or perhaps such civilizations are simply very rare, or maybe they deliberately avoid polluting interstellar space. Negative results are still results.
Feel bad, Leonard. Negative results are still results.
And this is how science works. But as the saying goes, what is important is the journey rather than the destination. The scientists are treating the moon as an archaeological archive for the entire galaxy. Traditional archaeology studies ancient human civilizations, but exoarchaeology would study civilizations that existed among the stars, not through radio messages, but through physical objects. Tiny pieces of technology that may have survived long after their creators disappeared. Perhaps the first evidence of another technological civilization won't arrive as a radio message from the stars. Maybe it has already arrived and has been lying silently on the moon for billions of years. If you got up to this point, please consider subscribing to the channel and giving a like to this video. If you are a regular viewer, you may remember that we explored in a previous video in more detail this branch of SETI, sometimes referred to as the Search for Extraterrestrial Artifacts, or SETA. If you need a refresher or you haven't seen that video, I invite you to check it out. Thank you for watching and being part of this growing community. That's it for now, and remember, the truth is out there.